So this is going to be a little introduction to gear sets, and really, I think the best way to do that is to use Inventor. It's really well done. So I am in a new um, Inventor assembly. I start with an assembly. It's kind of weird. And then I go to this design tab and I'm going to do some Spur Gear design. There are other types of gears that I can look at. And when you do that, let me cancel this quickly. You go to Spur Gear design, Spur Gear, and this thing comes up. And what we want to do in our class, there's lots. Gear design is a huge field all in itself. So we're going to just do one specific set of things. We're going to know the distance between the centers of, that's going to be a fixed number for us. And for right now, I've put down 3. And then we're going to put down a gear ratio that I want. As an example, 2. Where is this coming from? You've got an assignment to put some gear set data in where you have a center distance and a desired ratio. And then you're going to give me a whole bunch of data about that gear choice. And we're going to use Inventor to do it. Okay, so I've taken a center distance of 3 and I've got a gear ratio. And so then a whole bunch of stuff just happens. I'm going to calculate now. And you can see it did a whole bunch of calculations and it gives me tons of information, but let's take a look at it. It told me that I have 27 teeth on one and 54 on the other. So I could type that in. I've got 24. What do I have on this? Got a different one. I've got 3 and I've got 2. I've got 27 and 54. Okay. And I'm doing this module and teeth number. That's my easiest way. So I've got 27 and 54. And let's see what else I know. DP, a diametral pitch of 4.5. DP 4.5, so I can put that in here. Now, I don't have it on here because I'm going to get it all right here. But what is my actual gear ratio? Remember I said it was the output divided by the input. So I have to go look. The output is my big one. And the input is my small one. So it's 54 divided by 20. It equals this. So now I know about this gear set. I want to do one other thing though. There's tons of information in here that I want to keep. So let's take a look at here. Here's my gear ratio. It's exactly 2. Contact ratio, driven value. That's all about stress and strain and things. Outside diameter of gear 1. Outside diameter. This is all gear 1. Pitch diameter 6. Root diameter. This is all just incredibly good information to have for a gear designer. And it tells me my face width is 1. That's cool. And then I can come down to gear set number 2. Got an outside diameter of 7.5. Pitch diameter 12. And so on and so forth. Okay. So now I could also pick other values here. All sorts of things. Oh, this one says internal. I don't want that. Don't want internal. See if I can get a new one to come up. There we go. That's a little bit better. I accidentally had internal gear clicked. Got to make sure that that's not right. So now I've got, let me go back, it's a 24 and a 48. Got to be careful about that. 24, 48, and the DP, diametral pitch. How many teeth per inch around the circumference? 12. And my actual ratio stays the same. Let's go look at, see some of this again. So now I've got a 2.0. Now my outside diameter is 2.16. My pitch diameter, that's the diameter that the teeth connect on, is 2. Root diameter, so on and so forth. And now I have some more on gear 2, outside diameter. So that looks pretty cool. So now I want to get that information. And so here it is. What an incredible, and that's just this little notepad over here. And here's all that stuff. Parameters that are common to both gears. The gear ratio, the desired gear ratio, the diametral pitch, the pressure angle, the center distance. All of that is the same between the two. Now here, number of teeth, 24 and 48. Pitch diameter, 2 and 4. Outside diameter, gear 1, gear 2. So this is all really good information. You can actually make a snip of it. And I don't need everything. Probably down to the working pitch diameter. Oh, and the face width. And if I save that somewhere, I'll save it right there. Data. Then when I look at it here, I can put that image right in here. Insert and image in the cell. And now I can go browse for it. And I remember I put it right there. And isn't that cool? It's right there for me to look at. Zoom in on it and I can see it and all sorts of stuff. I can copy it. I can get it out. So this is a great tool. So what you'll find is often you don't know exactly what you want, so you put a table together. Okay? So I want you to put this table together using this Inventor. And voila. Says, do you want to really make that thing? Yeah, I want to make all that. And there it is. Click. And there they are. You could even take a picture of those if you would like and put that in there too. Now, if I just leave these alone, if I leave them alone, I can go back and find all that data again. What you'll find is if you start messing with these and do something to them later on, like put a bore in and some of those other things, you can lose that data. So you want to get that data output right away. Okay, so let's take a look and see here how this looks. Now you can see there's that pitch diameter, right exactly where they're changing. Let me get a better view. Now these aren't perfect. They're just standard gears, and you can see there's an interference there. It's not really there. They didn't do a perfect involute, and they don't have radii in all their corners. But you know what? It works perfectly fine for us. Okay? And you can see that right there, that's where they contact. Okay? And as this gear rotates right, it pushes this gear to right. That's clockwise for one gear, counterclockwise for the other. This is just kind of a cool thing to be. That's the root. Above this line is the addendum. So that's the pitch diameter or the pitch circle. You've got the outside diameter. You have the root diameter. And you do have a center. Okay. There's also something called face width. Now in this one, I made them both the same. That's not a requirement, but it's a standard way of doing it. We also haven't set materials. Your material for gears really makes a difference. So I'm going to make mine, let's see, what's a good one? What kind of other plastics might be good? Polypro, polyethylene, polycarbonate, those are all good ones. Probably the PET plastic is the closest to like 3D printed plastic, but all of these are good. Why don't I go ahead and make it a steel? So now I can go back in often and I'll make it an alloy steel. I don't know why I'm not getting. I'll figure that out at some point. So then I don't know why that's not loading. Well, we'll work on the material later. Looks like it made it steel, doesn't it? But it's just still saying generic. Um, but often these are two different materials because similar materials have bad friction. But for our project, we're probably going to leave them pretty much the same, at least for now. So there's your gearbox or your gear set basics. Okay, there you go.